Actually, the one that I kind of went through with you yesterday, but let's do it a little more formally here. So, and I'm going to be pretty quick on these. I'm going to depend on you to just slow me down or ask questions if you want me to stop. 'Cause I want to get through a couple different problems here. Okay, so if we have mass is suspended from parachute, descends vertically at a constant speed of 1.9 meters per second. A laser tracks the mass from a point on the level ground, 40 meters from the point where the mass will land. At what rate is the angle between the laser beam and the ground changing when the mass is 30 meters above the ground? So first thing, and let's just, I'm going to write this down like I would, if I were doing the test, this is how I would do it, okay? So what should I probably do first here? Make a picture for sure. Okay, so here's my picture. This is really just a triangle, isn't it? Right, I've got, here's the level ground, here's the object, right? And here's the laser beam right down there, right? So then we've got, there's the laser beam. Now, how do I label this? Okay, so this could be theta right here. Good, there's, and that's a variable, isn't it? So I want to label it as a variable. Okay, what else? The bottom is a constant, good. So we know that this thing is falling down like so. This distance is going to be what, 40? And we'll just, standard units. Units are all meters and seconds, looks like, okay? What about this vertical part? Let's call that y. I don't want to plug in 30 because that makes it look like a constant. Anything that's a variable, I should show on my picture as a variable. Now, I'll write down the snapshot values of the variables, but that is a variable, right? Okay, and that's really it, isn't it? That's my picture. So then what are my snapshot values?
30.
Okay, so y equals 30. Good.
Y dot
Okay, y dot
is
equals
1.9.
almost negative. How come negative? It's decreasing. Does that make sense? Okay, so y dot is negative 1.9. What else? What are we trying to find?
Theta dot.
Theta dot. Okay, so there's the stuff that I'm given. Now I can add to that list if I want to, right? What's next?
Parent function.
Parent function. Okay, the parent equation. So what's that gonna be? What's our relationship here between theta and y, given what we know? 10. Okay, good. So we know that the parent equation is just gonna be tangent theta equals y over 40, right? And so then, now we're all set up to do the calculus. What's next? Differentiate implicitly with respect to t. Okay, so what's the derivative of tangent theta with respect to t? How many layers are there? 2. Good. Derivative of tangent hand is derivative of hand is
Theta dot.
what about over here?
Y dot.
Yeah, good. Dividing by 40, that's the same as having a 1/40th out front, right? It's just a constant. So I just get y dot over 40. Okay, and so then now we want to isolate theta dot and plug and chug, right? So then if I isolate theta dot, if I solve for theta dot, secant squared is really the same as what in terms of sine and cosine? 1 over cosine. So I could, if I wanted to, I could just rewrite this as theta dot over cosine squared theta equals y dot over 40, and then just multiply both sides by cosine squared, okay? Okay, so what are my options then? I can plug y dot in directly but I don't know theta.
Use 30 and 40.
What is it again?
Use your snapshot values and the
Okay.
ARC 10 find it.
Okay, so I could find theta, couldn't I? I could find theta because I know that my snapshot values here, for my snapshot values, y is actually equal to 30, right? And so I could say, well, I can find theta then, right? I could calculate that theta is just going to be the arctangent of opposite over adjacent, right? And that's just a number, right? And so I could just plug that number in right there if I want to. That's one way to do it, okay? The way I would actually do it, honestly, is I would just make a reference triangle out of this and write them as a ratio. So if I want to, for my snapshot, right? For my snapshot, what is the value of the hypotenuse? 50. Right, it's just a 3, 4, 5 triangle. And if it wasn't 50, we could find it by Pythagorean theorem. And so then how could I rewrite cosine theta? What is cosine theta based on this reference triangle? And when I say a reference triangle, you understand what I mean, right? If I solve the triangles, what we would have called it way back in geometry, if I solve the triangle by filling in all the blanks, then any of the 6 trig functions can just be written as a fraction, as a ratio of sides, right? So what's cosine going to be? Yeah, 40 over 50, so 4/5. So we know cosine. So we know that cosine of theta is 4/5. And so coming down here, I could just write this as y dot was negative 1.9, right? And then cosine squared theta would just be 4/5 quantity squared, right? Does that make sense? Either way is fine though, really. I mean, they're both going to work. Divided by 40, and that's just going to give you some answer. Okay, make sense? Okay, one other thing then. What are the units of my answer going to be? They're going to be radians, yeah, not degrees, right? Why would it be degrees? And I know, I understand the point was, where a question was asked yesterday, well, how could it be radians if I put in degrees, or actually I never did put in degrees, but I could have. Well, what if I knew what this answer was in degrees? I could calculate theta right up here. What is this real quick? Somebody, just tell me, what is the arctangent of 3/4 in terms of degrees? What is it? 3/4, about
36.
How about in degrees?
0.0130.
Radians, right? Hold it. No, that can't be right.
36.8.
36.8,
7.
and then we could keep that in our calculator, right? So that's the angle in degrees, okay? So how could I use degrees there and come up down here with an answer in terms of radians? Okay, here's the answer. Here's why. Because the only place I would be using degrees is when I'm evaluating a trig function, right? But if we want to know how fast an angle is changing, I mean, how can I arbitrarily, this goes back to that discussion we had earlier, how could I arbitrarily just magically get degrees out of this? It doesn't make any sense, right? The cosine of some angle is just going to be a number. That's not an angle, right? That's just a number. How could the math gods give me back some rate at which the angles are changing and just magically agree on degrees when degrees are totally made up? They're completely arbitrary, right? They can't. The only answer that really makes sense here is the one representation of angles that's kind of transcends any measurement, the one that really makes sense, right? And that's radians. Think what radians are. Radians are just the distance, the arc length described by a certain angle on the unit circle, right? That's not going to change anywhere. That's always going to be the same. You see what I'm saying? Degrees, why did we pick 360? Because it's highly divisible. We could have picked 3600. it would work the same. But you think that this answer would have magically transformed based on if history were different and we picked a different number of degrees in a circle? No, right? And here's a short answer to that. We'll talk about this in physics quite a bit. Whenever you mix up linear and angular measurements, you always, always, always have to end up with an answer in radians. Okay, it's an angle measurement. You could never come out with degrees. Okay, does that make sense? I mean, you kind of have to just accept that for now, and as you do more math, it'll gradually make more sense to you. But okay, so our answer would have to be in radians. Okay, moving on. Let's do this one really quick. We did this one once before, so I'm going to be quick about this. This is a pretty cool problem. I think at the time maybe it didn't stick as much because it was pretty, related rates were pretty new. This is similar to something on the test. As a spherical raindrop falls, it reaches a layer of dry air and begins to evaporate at a rate that is proportional to its surface area, right? So if it's evaporating, think what that means. If it's evaporating, it's losing volume, right? So that's telling us that V dot is proportional to surface area, right? In other words, V dot equals Ks. Okay. Now, if we're going to say that K is, let's say that K is a positive constant, then I'd have to put a negative sign there, wouldn't I? Because it's losing volume. V dot is a negative number. The volume is decreasing, right? So that's true. Okay, now let's do a little calculus. If we want to show that the radius of the raindrop decreases at a constant rate. Well, let's just start with our parent graph. What is the volume of a sphere? Right, so if I implicitly differentiate, that's just a constant, right? So the derivative of r cubed with respect to t is what? 3r squared r dot, right? Well, 3 times 4/3 is just 4. So everybody agree that's it? Okay, well, isn't that the same thing as saying V dot equals, that's surface area, right? S r dot, right? And so then if we know that V dot equals negative Ks and V dot equals S r dot, well, by substitution, doesn't that just tell us that
K equals R dot.
S r dot equals negative Ks? So in other words, r dot is negative K. The radius is changing at a constant rate. It's decreasing at a constant rate.
Is it negative because it's students?
Right. The negative just comes, if we define K as being some positive constant, then we have to put a negative sign there because it's evaporating, right? It's losing volume.
Oh, so the radius is increasing just in case.
Say it again.
If the question says that the radius is increasing.
Oh, yeah, then it would be positive. Right. Okay. Make sense? So that proves it right there. The fact that we can say r dot equals negative K, where K is a positive constant, that we just proved it.
That's all.
Yeah, that's your answer, right? And I would, on a test, I would say, okay, I would describe it a little bit. I would say, okay, therefore, if K is a positive constant and r dot equals negative K, then that implies that r dot is decreasing at a constant rate. Yeah.
Do you have to put K as negative, or could you just have K? Because I feel, it seems like K would become negative.
It would. So you could say, right, but then you would want to say, okay, what Nick's saying is, do you have to do this? No, you don't. You could just leave it as K, but then you'd want to specify in your answer that K would, based on this statement right here, if when it reaches a layer of dry air it begins to evaporate at a rate, that implies that K would be negative, right? Because it's important that you realize that r dot is not just a constant. It has to be a negative constant because, look what the question says. You want to show that the radius of the raindrop decreases at a constant rate.
But if you leave it as K, don't you show that it can increase and decrease depending on whether or not it's evaporating? Because if you look at that in reverse, then K would be positive.
Okay, right, you do, but
Just specifically to this problem because it says evaporate, it wants you to.
Exactly, and the thing is, I see your point, but you want to be careful with that, because sometimes, like, maybe not in this case, but oftentimes, you can't generalize like that, like in physics. Like maybe when something, what I'm saying is like just perhaps, if it went the other direction, and it was, I don't know, what are we doing? If it were water were condensing on the raindrop, which is I guess the opposite of evaporation, right? Then maybe that's not linear, you know? I mean, you don't know that for sure. What this is just telling us is that evaporation has this relationship.
Can you say your explanation?
What's that?
You said that explanation.
Yeah, so then this tells us if R dot equals negative K, and K is a positive constant, then this is telling us that R dot is decreasing at a constant rate,
You mean K is negative?
or the radius is decreasing at a constant rate. Right, so if K is negative, if you didn't do it this way, if you just left it as K, then at the end, you know, somewhere in there, you'd have to state, somewhere in here probably that, okay, well, if V dot is decreasing, then that means K is negative. I prefer to do it this way, because then you can see the negative sign right there. But it doesn't, you don't have to, right? You could if you wanted to. Let me say that again, that wasn't very clear. We could have said this, we could have said V dot equals Ks right here. But if we did that, the context of the problem would tell us that K would have to be negative, right? Because the volume is decreasing, that's what evaporation does.
I want the radius to be a negative constant.
Right, exactly. So if K were negative, then our answer, if we had done it this way, our answer would have ended up being R dot equals K. But we know that K is a negative constant, so that says the same thing. Right? Did that answer your question? Okay. Okay. So how about one like this? An airplane's flying at an altitude of 5 miles and passes directly over a radar antenna. When the plane is 10 miles away, so S equals 10, the radar detects that the distance S is changing by a rate of 240 miles per hour. What's the speed of the plane? The picture's already kindly drawn for us here. So what are our snapshot values? Notice that this is a 5, it's not a Y, right?
S equals 10.
S equals 10, good.
S dot
is
Equals
240.
240, and what are we looking for?
X dot.
X dot, because that represents the speed of the plane. It's flying horizontally, right? Okay, how are we going to do this one? Pythagorean theorem, sure. Right, everybody see that? Do you see the difference here? We don't need an angle, do we? Right? The angle's not given, nor is it asked for, right? It'd be easier to do this with Pythagorean theorem. Okay. So then what's our parent function?
A squared.
Yeah, okay, so x squared plus 5 squared equals
S squared.
s squared. Good. And if I differentiate, don't I just get 2x x dot, that goes to 0, right? The derivative equals 2s s dot, right? And then if I divide each side by x, I get x dot equals s dot over x. Okay, well, x isn't given to us directly, but we could easily go back up here and add x, couldn't we? Right? Because we know what the values are in our snapshot. In our snapshot, s is 10, and so, you know, we can solve for x using Pythagorean theorem, right? So x would just be what? Square root of
75.
75, 100 minus 5 squared. Okay, now plug and check. We got it. Okay, make sense? Okay, I went through that pretty fast, but we okay with that? Okay. How about this one? So this is, if I gave this to you on a test, I would give you some additional information. You have to know, we have to know the physics equation that went with this, wouldn't we? If we're dropping the ball from the height of the lamppost, right? After 1 second, we'd have to be able to calculate how fast it's going, right? So and how far it had fallen. So here's our picture in this case then. Our picture just looks like we've got this, we've got our triangle, right? Okay, and then we would need to know probably, what do we probably need to know here? That distance is 12 meters. What are the variables going to be? We're trying to figure out how fast the shadow's moving across the ground after 1 second. So what could we, there's multiple ways to do this. What would the variables be?
Distance between the shadow and the lamppost.
Sure, that's one way we could do it. We could say that this distance from there over to there, we'll just call that x, right? That whole distance. Okay, what else? Something else we probably need
We
here.
look at the angle from the light to the ground,
You could.
if that's.
Do we want to introduce an angle, though? We don't really need an angle, do we? Could we instead, what about this? What if we just said, like, here's the height of the ball, right? That's a variable, isn't it? Let's just call that y. And what can you tell me then? What's the relationship here probably? Well, let's just figure out what we're trying to find. We have to know this part too. So I would give you, there's some physics going on here, isn't there? So what would the equation be? I would have given you maybe this equation. Y, the distance that the object has fallen, you guys can do this from physics, right? Would just be, what? If it's starting from rest. Right, so that's going to be delta y equals v naught t plus 1/2 a sub y t squared, but that's 0, right? And so we'd end up, I would have just given you this equation. It's fallen by an amount. A is negative 9.8. We're doing meters here? Yeah. Times 1/2 is negative 4.9. So that's how much it's fallen, right? After 1 second, how far has it fallen then? 4.9, yeah. So you know that this distance right here is 4.9. So what's the initial value of y going to be? 15.1, right, yeah. So we know, we've started to make our list down here of snapshot values. We know y is 15.1. What about the speed? We also know that v equals v naught plus at. So for us, that would be v equals negative 9.8 t. Right? So what's the speed? Negative 9.8. Now what is that speed going to be in terms of our picture? Yeah, but what's the variable? It's a rate, right? What dot? Y dot. Yeah, it's y dot, isn't it? That's the rate at which y is decreasing. Y is the height, right? So we know y dot equals negative 9.8, and we're trying to find x. Agreed?
X dot, right?
X dot, yep. Okay, well, what's the relationship here? We can't really use Pythagorean theorem this time. But what do you see up here? It's geometric, isn't it? We know the big yellow triangle has a height of 20, right? And the width of the big triangle we're going to call x. Okay, what about the little triangle? Has a height of y. By the little triangle, I just mean that one, right? Has a height of y and a width of, what, x minus 12? Okay. What can you tell me about those two triangles? They're similar triangles, aren't they? They share an angle, and those sides are, right? So I could set up a ratio here. I have similar triangles. So the ratios of corresponding sides would have to be equal, right? So what's our parent equation? Well, how could we set up a parent equation for that? So big, how about we just do big over small? So 20 big over small, 20 over y equals x.
X over X minus 12.
There it is. Okay? And I could either, I could cross multiply if I want to, whatever, doesn't matter. Might be easier to flip this around so the y is on the top, right? Write it as y over 20 equals x minus 12 over x, which is the same thing as 1 minus 12 over x, okay? If I split that into separate fractions. And now all I have to do is just differentiate, right, implicitly. And this is a pretty hard problem. I mean, this is way harder than I think the test, I think. But, so what would I get here if I implicitly differentiate?
Y dot over 20.
Okay, so y dot over 20 equals 0, right? Oh, how do I do that? Hang on, I gotta do that.
12X dot.
Equals, yeah, so that's the same thing. I could rewrite this as 1 minus 12 x to the minus 1, right? So what's that going to give me then?
12x.
Okay, good. 12x to the negative 2 x dot. Good. Right? Okay, and then I know, well, I don't know what, I don't know what x is. It's not given to me directly, but I can find it, right? Because during our snapshot, we know some values here. We know that what's the value of y is 15.1, right? Right? So if y is 15.1, then I should be able to figure out what this is too, right? Does that make sense? Right? Okay, so how could I solve for x then? What's the ratio I could set up there to solve for x? 20 over x, right? Or 20 over 15, that's what you're saying. Yeah, we did big to small, that's fine. 20 over 15.1, right? Big to small equals what? X over x minus 12. And I can solve that for x, can't I? If I cross multiply, right? If I cross multiply, I would just get 20x minus 240 equals 15.1x. So what am I going to get? 4.9 x equals 240. So x is just some number. Right? And then I could plug that in down here. I could plug that in for x. We're trying to find x dot, right? We know y dot, so we're essentially done. Right? Y dot was, what did we say it was, negative 9.8? Okay, so we could plug numbers in and isolate x dot. Right? Does that make sense? If I did one more step here, if I multiplied both sides by the reciprocal, x dot would equal x squared y dot over 240. If I just multiply each side by x squared over 12. And then I can plug stuff in. So what's this give me? X equals 240 over 4.9. We'll just leave it as a fraction. So I end up getting 240 over 4.9 squared times negative 9.8 over 240, whatever that is, put in your calculator. Okay, I'm just going to get some number. Okay? What's probably, I mean, this is kind of tougher, but what's probably the important part of this whole problem? How do we get our parent equation? Similar triangles, right? That's really what, makes this thing. When you see that, it's not horrible. I mean, there's there's more work to do on this one. You gotta go back and calculate X. I mean, there's some geometry to do, but no individual part of that is really horrible. It's just a lot of stuff put together. But that's a pretty hard one too. I think that's definitely an order of magnitude above anything that you guys are doing on the test. But it's a good one maybe to look at. Okay? Does that help a little bit? Okay? I'll put this recording up tonight. Put it up, in fact, I'll do it right now, just to make sure it's up.
Do you think in the time we have we could look at?
Yeah, I tell you what, here's how I wanna treat that. I'll let you go back and redo problems, but I don't wanna, I want you to, maybe to do the problems on the same day that you look at them. Okay? How's that? So I don't think, there's not any time now, so when are we out of here?
10 minutes.
Well, if you wanna do one, you can, that's fine. So I don't care, if you wanna try one, go ahead. Does anybody want it?
Yeah.
Okay. All right. Okay, right there. Okay. Settler, and these two. You good? Yeah, yes, no. You wanna do it? Really? There we go. Would you hand those back there? Paige, you gonna, yea or nay? You don't have to, you wanna do it? You wanna, okay. Richard, I think that's. Okay, but did you guys turn it into? Oh, okay, gotcha. All right, you wanna start on one?
Yes.
Okay. There you go. There you
Here,
go.
mister, I'm good.
You're good?
Yeah, I
Okay.
feel comfortable.
Okay. Okay. Yeah. You already got that one? You wanna do a different one?
Yeah.
So which ones have you done? One to four? You wanna do that one? You wanna write it? Which one, this one? You don't wanna do another one, Tyler, today? No, okay.
I don't wanna rush myself.
What's that?
I don't wanna rush myself.
Yeah, that's fine.